Like giant exclamation marks, skyscrapers punctuate the story of our urban development.
People always want to reach. There's something heavenly about it, and people have wanted to race for height forever.
Developed by the pioneers of architecture in the late 19th century.
They were, at the time, the equivalent of our going to the moon.
These magnificently designed tower giants urbanized some of the greatest cities in the world.
It's about defying gravity and leaving a sign of humanity.
From Chicago to London, from Tokyo to Dubai, skyscrapers have and continue to define our contemporary way of life. In a time that quite literally soared, the roaring 1920s had people feeling alive. Big cities were thriving, each developing a distinctive cultural edge. But like most good things, not everything lasts forever. When the Great Depression descended on America, it cast a large shadow across the country. In the aftermath of the stock market crash of 1929, millions of people were out of work. Hundreds of thousands of families were evicted from their homes, and the industry collapsed. By 1931, 6 million people became financially and emotionally destitute. 10 years later, the country began to recover from the financial setback, thanks in part to President Roosevelt's New Deal to stimulate the economy through construction. But the skyscraper business continued to struggle.
For the most part, from 1932 to really after World War II, there were essentially very few skyscrapers built. Perhaps the big exception is Rockefeller Center.
The construction of the Rockefeller Center in New York City was the largest privately owned building project of its time. Employing over 40,000 people, the building was conceived as an urban renewal plan to help revitalize Midtown Manhattan. The project was spearheaded by John D. Rockefeller, Jr., son of the oil industrialist and philanthropist John D. Rockefeller, Sr.
The land had been owned by Columbia University, so John D. Rockefeller signs a contract to take over control of the land.
He wanted it to be a series of buildings. There was one main skyscraper, but then there were around it lots of plazas, and they even had a skating pond. And then they had the place where they lit the Christmas tree every year.
Back to America, and this time it's winter sport amid the towering skyscrapers of Manhattan. A new skating rink has been opened in the heart of New York shopping center. Rendezvous where you can cut a few capers on the ice during luncheon and cocktail hours.
Part of the plan was to include an opera house and make it like a civic center. But then the Depression came and the opera house deal fell through, but they were determined to make a commercial project out of it.
Between 1932 and 1940, 14 buildings were constructed on the site, including 30 Rock, otherwise known as the RCA building.
The Rockefeller Center opened up a new vision about the city, which was the modernist vision, perhaps.
We tend to think about tall buildings as these pieces of sculpture, these icons standing alone against the skyline. I think a great example is Rockefeller Center, where a multi-block compound was designed at the same time with a single structure in the middle and then smaller structures around it.
Rockefeller Jr. invested $100 million into the complex. Through his investments, the project allowed tens of thousands of workers to regain their ability to provide for themselves and their families.
There was a very interesting description of the Rockefeller Center from historian Siegfried Gideon, who used the Rockefeller as a quintessential example of the concept of space, time, and architecture. So in that sense, the Chrysler and the Empire State Building were still building that you could appreciate from a viewpoint. The Rockefeller Center, you had to experience it moving.
Primarily, it was driven by the commercial interest, combined with having this tremendously large plot of land and having a team of architects and engineers who were sort of civic-minded And we're thinking about how to project the future within the heart of Midtown.
Regardless of when or where they were built, a skyscraper's basic structure hasn't changed over time. From the earliest skyscrapers to today, most still share many similarities.
Engineers will think of tall buildings as a kind of perfect statement of the principles of engineering, the economy of holding up a structure with the least amount of materials.
We have to do certain things. We have to, one, make sure the ground doesn't sink below us, so we have to put in our foundations. We have to build in systems. We have to have floors, which we walk around on. We've then got the columns that support those floors.
The correspondence between buildings and our physical anatomy is pretty strong. They have circulation systems, they have electrical systems, like our nervous system. They have a skeletal system, like our bone structure, and they have a skin.
You have to have these mechanical systems that enable the building to breathe and cool itself and regulate itself. And so a human is not a bad analogy for a tall building.
The stock market crash and the Great Depression left the country in a state of economic crisis, bringing the tall building industry to a halt. But after World War II, cities like New York and Chicago experienced an industrial revitalization, restoring faith that the industry could and would boom again.
So after World War II, you have several forces at work. One is the need to build new modern high-rises. Then there's sort of the new and technological innovations that had then become much more readily available.
Those of us who have been following this subject most closely expect that welding will displace riveting entirely for building construction.
Now, what happened with World War II? The military industry used welding a lot more in shipbuilding and aircraft building. So a lot of riveters were converted to arc welding techniques. What that meant is that you could have buildings that were easier to prefabricate, in part, with welding that was high-strength bolts that were also becoming more available. It enabled to have connections that could be done in a factory and completed faster on site, so there was less hurdles to overcome in order to build high.
Significant innovations in building construction were on the rise. The type of glass installed in buildings was changing from pre-war plate glass to a post-war float glass system. Technological advancements in air conditioning and fluorescent lighting systems provided workers with more flexibility and comfort and improved a building's rentability.
One of the things about a tall building is that you have to design them like a Swiss watch. You cannot have wasted space, because if you have wasted space, you're repeating that wasted space so much.
There was definitely a period of time where designers were trying to find the right expression for a skyscraper. What does it want to be? How do I do it economically?
And so then you kind of see the economic demand, the technological innovations, and then architectural, zeitgeist of the day, the International School of Architecture, putting forth their ideas about how tall buildings should be built.
The post-war era brought forth a new generation of Chicago skyscrapers. As the world was evolving, so was architecture. Now architects were designing buildings with a functional style. Residential and commercial buildings were developed to appear sleeker, a departure from the mixed decorative styles of the past. As modernism began to lead the charge, a new age of design was emerging. Its founders became known as the Second Chicago School of International Style.
People in the post-World War II era really wanted to set the past aside and look at it as behind them and look forward into the future. The most rapid way to do that was through an architecture or a style that purported to be international in its influences, but was seen as being the epitome of efficiency and modernity.
The Second Chicago School influenced a new generation of designers, bringing forth an energy and innovation to architecture. But one pioneer stood out from all the rest. Ludwig Mies van der Rohe, or simply Mies to the design world, was one of architecture's most towering figures.
Mies was about aesthetics, clearly. His buildings are functional in some ways, and they look functional. But more importantly, they're beautiful in terms of his proportions that he picked. He had an eye for it.
As technology and construction evolved, so did the American skyscraper. the use of steel and glass became the signature of the international style.
Steel skeletons were exposed for their honest expression of structure, and the glass curtain wall was a membrane that surrounded and expressed those frames.
Ornamentation was out, and minimalism was in. As Mies said, less is more. Standing at 516 feet tall, this New York City building was one of the most iconic examples of functionalist aesthetic during the rise of modern architecture. Later, as modern architecture dominated urban skylines, sleek, glassy skyscrapers were taking over city streets all over the world. But all that glass needed to be cleaned, and with buildings getting taller, innovators looked to new technologies to build more efficiently, not only inside the building, but also on the outside. Across the world, a new standard for style was established in the 1950s. In a time where modernism was king, leaders like Ludwig Mies van der Rohe were influencing how designers approached architecture. The first tall office building Mies van der Rohe designed was the Seagram Building in New York. Located on 375 Park Avenue, this 38-story masterpiece was commissioned by Seagram's founder, Sam Bronfman.
Out of the dreams of one industrialist, this great new edifice came into being, the skyscraper that would become a landmark. The most beautiful tower ever to rise on Manhattan's skyline.
Through every phase of construction to its completion, this sleek avant-garde structure captured the imagination of the nation. Floor-to-ceiling windows, made from gray topaz glass, offered protection from the glare and heat of the sun, without any real compromise to the site's natural light.
There had been visions of all-glass skyscrapers since the early 20th century. After World War II, our ability to create large expanses of glass became much more economical, and the result was the ubiquitous glass skyscraper of mid-century.
Specially devised pinkish-gray heat and glare-resistant glass. Windows of this glass are easier on the eyes of those who inhabit the office building.
Mies van der Rohe sort of placed the structure within, but then he added structure to the Seagram Building just to make it look like structure.
The Seagram Building was considered an icon of 20th century architecture, made of steel, reinforced concrete, and glass. It was the epitome of international style.
It wasn't necessarily a very efficient skyscraper, but what it did, it celebrated steel welding, as Mies did also in other projects, and it created this iconic image about the tower.
And no city was really advanced or developed without having its own kind of glass skyscraper.
Modern American architecture had arrived, but it wasn't cheap. The use of materials like marble and travertine caused the building's final cost to skyrocket. At its completion, the Seagram Building was considered the most expensive skyscraper of its time, costing $41 million to build. While the Seagram is arguably the most impressive international-style building in Manhattan, the Lever House created its fair share of attention. Designed by Skidmore, Owings, and Merrill, the Lever House was a significant building of its time, transforming the evolution of skyscrapers.
Lever House had a podium element with the kind of tower above to create a space of ground that doesn't dominate, that defines a site and kind of set back the tower above. Lever House is perhaps most well known for its single-skin glass facade, and while that created a sleek modern aesthetic, what it meant is the building heated up very, very quickly in the summer and got pretty cold very, very quickly in New York's winters. And so the building became one of the first that was totally reliant on air conditioning and artificial heating.
Since the building was the American headquarters of Unilever, a multinational soap company, cleanliness was also an important consideration.
These men made a contribution to the science of washing that made Mrs. America stand up and cheer.
It was one of the first buildings, if not the very first building, that developed what we refer to today as the BMU, the Building Maintenance Unit, which is a cradle that goes on top of the roof that is attached to a crane, and it's used to clean the facade.
Using this automated cleaning structure, it took workers just 6 days to clean the entire Lever building, proving that this system was an efficient way to get the job done.
The higher you build, the bigger the window cleaning problem. This must be one of the few jobs where you start at the top and work your way down.
Fear of heights? Not an option.
So when you had windows, which you did until you had air conditioning in the middle of the 20th century, you had window washers who hung out outside those windows and they strapped themselves in, and I could never do it because I'm scared of heights.
The taller the skyscraper, the greater the risk. So leather harnesses and anchor bolts were invented to prevent window cleaners from falling.
Hold tight, everybody. We're gazing over the edge of the highest structure in the world, watching a crew of window cleaners giving the Empire State Building its first shine.
But as architecture was moving towards a functional international style, the shape of the building was evolving. So glass facades were becoming increasingly more difficult to clean. Despite improvements in harnesses and support structures, over time, it's still considered an extremely dangerous job. In the mid-1950s, aluminum was quickly becoming the new go-to building material. But architect Frank Lloyd Wright challenged its worth. He set out to steer the tall building business in a different direction with his first multi-purpose tower in Oklahoma, in the center of Tornado Alley. With wind speeds over 300 miles per hour, it is not the ideal city to build tall buildings. But Oklahoma defied the odds, adding several skyscrapers to its skyline, specifically in the Bartlesville's business district. At 19 stories high, the Price Tower became a symbol of Oklahoma's prosperous landscape.
Price Tower by Frank Lloyd Wright was an interesting foray away from the glass box which was here. You had an asymmetrical geometric tower which embraced shading. The Price Tower is perhaps one of the first built tall buildings that tries to be a mini vertical city. And Frank Lloyd Wright came up with the analogy of a tree where the core was like the trunk and the floor plates were like branches projecting out from this. Now that's quite a unique way of doing things.
Frank Lloyd Wright had an enormous influence in the conception of tall buildings. He didn't necessarily do the classic tall buildings that we will recognize today as pace setters, but he gave some vision.
In the same year Price Tower was completed, Wright stood before reporters in Chicago and unveiled his plans for the state of Illinois.
He envisioned a mile-high skyscraper, 528 stories, and even went so far as to examine the technological challenges to make that achievable. So he envisioned 5-story elevators which were nuclear-powered, which would serve the upper floors, for example, technologies we don't even have, obviously, today.
Frank Lloyd Wright's vision for Illinois never got off the ground, but it kept the dream of building to the sky alive. But in an economy that was just getting back on its feet, developers had to carefully consider how much to spend on building skyscrapers. And for those who believed architecture should reflect historic traditions and social order, building a skyscraper that would redefine a new artistic perspective wasn't an easy task on a budget. For all their inspiration and innovation, skyscrapers are difficult to engineer and expensive to build. Each additional square foot increases its price tag. So what are the economic drivers for building taller skyscrapers?
So Cass Gilbert, the architect of the Woolworth Building, famously said that the skyscraper is the machine that makes the land pay. Fundamentally, he was describing the skyscraper as an instrument for capital.
So there is a premium to pay for height, and that increases the cost of tall building design and construction. So if you calculate the cost of a tall building per square meter, for example, is considerably higher than a building that is not so tall.
They're also more inefficient, which from a developer's perspective is very critical because it means that for every square meter of area he builds, he gets less of that area to let to tenants because they require larger cores and larger structures and more lifts to move people up and down, and they take longer to build.
In other words, there's a relationship between building taller, economic development, and the demand for height.
You see tall buildings going up, super tall buildings around the world. That's partly because there are people who are willing to pay for a suite on 120th floor of Burj Khalifa just so that they can say that we have an office at that location.
Perhaps one way of putting it for tall buildings, there's the 3 F words about tall buildings, right? Function, finance, and fad.
For me, as a cost consultant, a good skyscraper is one that creates delight in terms of how it looks, but at the same time, it's efficient and economic.
Inevitably, cities change over time. When cities experience periods of creativity and growth, a city can reshape itself by providing new structures. In the United States, by the late 1950s, the demand for modern corporate buildings with custom features and forms took hold of places like New York and Chicago.
The skyscraper as we know it today originated in America from a point of view of the building typology, from a point of view of the technologies that are involved, from the point of view of the real estate developments that are associated with that.
There are 2 original things in America. One is jazz music and the other skyscrapers that have been exported everywhere.
There was no European architect who could have imagined to do architecture by taking a floor plan and stacking it relentlessly again and again and again and turn it into a building.
Shortly after modernism took hold of America in the mid-20th century, other countries began to push the boundaries between creativity and architecture.
That seed of the American building was planted elsewhere. Particularly after World War II, it started to develop in Europe. You see the countries have an instinct almost to plant skyscrapers in their city to reaffirm the importance of their location.
One of Europe's earliest modern skyscrapers is the Pirelli Tower, a 417-foot marvel in Milan. From above, the skyscraper is shaped like a 6-sided diamond, an idea architect Gio Ponti believed represented the completeness of design.
Pirelli Tower was a concrete tower, and that wasn't necessarily a common thing in those days. But the material, concrete in this case, was tapered, and it would reduce itself to its minimum structure at the top of the building, because gravity laws at the top of the building would be less than the ones that would be at the base of the building. And so it created this interesting idea where concrete could be somehow molded differently as you go up on the building.
Thanks to Gio Ponti and his engineer, Pierluigi Nervi, the Pirelli Tower inevitably brought the American-style skyscraper to the country. For the public, the project served as an innovative achievement in Italy. A visual representation that pushed the boundaries of architecture and engineering on an international level.
Through the work of Pierluigi Nervi, we can find a link between that and other buildings in other parts of the world. Nervi collaborated with an Australian-born architect, Harry Seidler, who developed a generation of tall buildings for Australia, which in fact were based on concrete as the main technology.
In the 1960s, concrete became an increasingly popular material in building construction. Concrete allowed engineers to create bridges and buildings that were lightweight and curvaceous. As architectural design made a departure from the old to the new, traditionalists began to fear the worst. New Yorkers feared their city was becoming overdeveloped, all due to the inconvenient realities of modernism. By the 1960s, most people had embraced modernism. All over the world, architects and engineers were building skyscrapers taller and higher than ever, taking risks and producing structures that took innovative leaps of faith. But too much change too quickly can sometimes have the opposite effect.
Modernism had an enormous and detrimental impact on cities through planning and misguided planning. Robert Moses in New York City is one of the most famous examples of a planner who wiped out complete neighborhoods, bringing expressways through cities.
The rules of the development game in New York were changing rapidly. As a response, action groups were formed to advance public awareness. By 1964, a battle between urban development and preservation had taken hold of the city. The Pan Am Building, now known as the MetLife Building, was one of the biggest and most bitter battles over a construction project in the city's history, with critics declaring the building the ugliest thing to ever rise from the Manhattan skyline.
One of the things that was most criticized was its location, which denied the whole idea of the Rockefeller Center and the space-time architecture. Now suddenly you have a slab that is blocking the view at the end of the street.
The size of the 59-story tower was reduced, to some extent, by the angles on its north and south facades and the indentation of its two mechanical floors, housing the building's enormous heating and cooling equipment.
Over Grand Central Terminal, the new Pan Am Building rides out a controversy that has architects and city planners in a dither.
But it was also perhaps the beginning of questioning what modern buildings were about. Pan Am Building was defined as a behemoth, right? And so there was a moment where things started to change.
The New York City Landmark Preservation Commission was established in 1965. Its charter was to protect the Big Apple's architecturally, historically, and culturally significant buildings, including many of its soaring skyscrapers.
New York has a mix of skyscrapers that go back over 100 years. So how does one place value on both tradition and change?
I think people think of the New York skyscrapers as kind of members of an extended family. It's part of what makes New York, New York, and when you move to New York, it becomes part of your identity. This idea of the skyscrapers being part of your identity also then creates this tension with preservation.
Buildings that were ugly at the time are now considered treasured landmarks and become protected. So one's opinion about the quality of a skyscraper often changes with time as well.
The question then becomes, do you hold on to buildings that might be beautiful, but then sacrifice some of the modern needs that the city, expects?
In Chicago, the inner city lost close to 700,000 of its residents, many leaving to pursue the new American dream, which was putting down roots in the suburbs.
Tall buildings were arguably, in the eyes of the general public, an expression of greedy corporations. But most of all, what was criticized was this idea of the 9-to-5 life. You go into a building, you work, you walk out, take the car back on the highway and live in the suburbs. And the city is left with these totems that are empty.
In order to keep the city alive, local councils focused on revamping downtown neighborhoods. Unions pushed for workers to move back to the city, arguing for better jobs and better pay.
The requirements for modernization became an imperative, and the first priority was housing.
Breakfast time at the apartment. Things are starting to move.
One complex that quickly became the testing ground for mixed-use skyscrapers was Marina City, on the north bank of the Chicago River. Central to the design were two corncob-like structures that incorporated office and residential spaces, allowing people to live in the marketplace, literally commuting to work via an elevator. Inspired by the futuristic interpretation, more than 3,500 people rushed in applications to rent the 896 available apartments.
These beautifully evocative circular buildings where the generosity of the design is the balcony. The balcony space, the outside space becomes everything. And sitting out on those balconies, looking south across the Chicago River, I can't think of many better places to be.
The innovations pioneered by Bertrand Goldberg's City Within a City would completely change the future of urban living. But if the future of building is to create cities in the sky, how will their design hold up to the natural elements? By the late 1960s, living in the city wasn't as popular as it used to be. More and more middle-class workers were abandoning the city for the suburbs. But thanks to architect Bertrand Goldberg, Chicago was forever changed when it ushered in a reinvigoration for city life. Marina City, located in Chicago's Loop region, influenced both form and function of architecture, introducing a new approach to urban planning by catering to commercial, retail, residential, and entertainment sectors through mixed-use buildings that soared to the sky.
That's in part a portfolio approach to balance against any one sector going down. And so if you do have something where you have some condos that you actually sell, you have a hotel, you have office, and sometimes you may have a theater or transit hub, you've kind of got enough.
So it's not an office building which goes dark at night, right? It has its own life to it. It really is this 24-hour community that is always a part of the city, day or night.
Goldberg's intention for Marina City was a success. Now more than ever, Chicagoans were embracing the idea of living closer to work than ever before. 80% of residents who worked within the development area could walk to work.
There are a lot of people who want to live in large cities and they want to work there. Their lifestyle is better. They don't want to commute back and forth.
It's all about finding the right blend, trying to keep neighborhoods alive, which drives investments in the area, which brings in social aspects to those areas and creates community and gets people proud about where they live and actually enjoying where they live.
It's no surprise that building a city within a city comes with its array of challenges. Not only do engineers and architects need to create a thriving way of life inside of buildings, but they also have to construct a building strong enough to withstand the elements on the outside. In cities all over the world, engineers must consider the gravitational and lateral load of their buildings during construction in order to counteract the effects of the wind.
When we build the tallest buildings in the world, the wind is our foe. The wind pushes on tall buildings and creates a lateral load that we have to resist using additional structural material.
Smoke is passed into the airstream so that the airflow can be recorded on film. This research will help to find the best materials and design for future high buildings, also the best arrangement for grouping buildings in relation to the prevailing winds.
As long as you are within a limit, maybe 10 stories or so, gravity load will control, okay? But as soon as it goes beyond that, then wind starts controlling, depending on the slenderness of the building also.
If you go against the wind, good luck to you, because it takes no prisoners, by the way, the wind. The speed of the wind obviously increases the higher you go.
And that's why, over the years, a number of different evolutions of new systems for tall buildings have come up.
One of the most innovative systems was developed by Fazler Khan, a structural engineer at Skidmore, Owens, Merrill.
Khan realized that we didn't just have to have lots of columns going through skyscrapers. We could start to use the perimeter of the tower.
And Khan was very clever in defining a chart that said, well, depending on your height, you have to use different systems. So you can't use a simple frame building like the Chicago School kind of buildings if you're going over a certain height limit.
The future of building to the sky was tubular, and for all intensive purposes, limitless. The first building reinforced by Kahn's braced tube system was the John Hancock Center, a 1,128-foot tall building giant on what is referred to today as Chicago's North Michigan Avenue.
With the brace tube system, you put the bracing along the perimeter of the building. So it becomes an external system, and it makes the walls really, really stiff in their own planes.
So I have a sheet here, and you see that if I hold it like this, it cannot even resist its own weight. If I take the same sheet and roll it into a roll like this, I can hang this stack of papers from it. So this has a lot more stiffness than the sheet of paper did. The tube doesn't have to be round, it could be rectangular, it could take whatever shape. The key is that we're providing additional stiffness by distributing the material in the cross-section differently.
On the John Hancock Tower, all of the columns are working together. Because the rule of the Hancock is every time a diagonal crosses a vertical, it happens at a floor line. And because of that, you can move loads all over the place. And so that all the columns are resisting the wind, not just the ones in the corner.
Kahn's system put an entirely new spin on the age-old practice of creating load-bearing walls, which eliminated the need for inner support beams. The Hancock Center was widely praised for its structural simplicity, its gently sloping facade, a radical departure from established design at the time, moving towards a style that captured the essence of the machine age of architecture. Historically known for its iconic Golden Gate Bridge, the 1970s was a period of change for San Francisco, and a new addition to its skyline evoked a less than peaceful, loving feeling. While the 1970s brought forth unprecedented progressive changes in society, it also produced a wave of radical ideas from architects who were creating out-of-the-world concepts in response to the major shifts taking place across the world. San Francisco was the epicenter of radical change. Known for free-spirited style, the city's architecture fell right into the time period, blending styles together and creating a new design movement, postmodernism. But one addition to San Francisco's skyline was totally unexpected.
The Transamerica building was a building that was trying to do something else rather than the ubiquitous towers. It was a pyramid, which is a counterintuitive approach to a tall building where the maximum benefit is for the top floor.
The 853-foot, 48-story monoliths, designed by William Pereira, became the compass point that polarized the nation. Some critics said it was so interested in form, it completely compromised on function.
It was the object of stigma because it was the tower that somehow represented yet again another tall building that erases some historical urban fabric.
Pereira argued the pyramid should be seen as a statement of architectural sculpture. But critics knocked it down for its lack of practicality and an inefficient use of funds. It started to become apparent that the general public suddenly despised everything tall buildings represented.
Then the cultural movement of the conservationists, like in San Francisco and in other cities in the world, started to attack this idea that buildings were monotonously destroying the skyline to some extent with their presence, but they were also destroying the historical fabric of the cities.
A seismic shift was on the horizon, one that would shake the foundations of urban culture throughout the world. Architects and engineers were used to appeasing their corporate clients. Now it was clear. Engineers had to consider their obligation to the general public and future generations. So what is the future of building to the sky?
So we're building literally hundreds and thousands of buildings around the world, 200, 300, 400, 1,000 meters high, with absolutely no idea about their true life cycle.
You can't exactly pour a bucket of acid on top of a building and melt it down. It's very difficult or risky to demolish these buildings by imploding them. We build these buildings as though they will be permanent fixtures on the face of the earth.
We often hear architects say that the skyscraper is like the modern equivalent of a Gothic cathedral. But in terms of how long it's going to last, it isn't at all. It's an ephemeral, throwaway architecture.
I don't think any developer sits back and thinks, in 50 years, I'm just going to throw this building away. But the world around a building might change quite dramatically.
A lot of thinking these days has to do with, can we design robust structures that are not so tailored to certain programs so that they could survive these kind of transformations over time.
In time, we'll see more examples of buildings enjoying second or third lives and being refreshed and renovated and altered, but also designers giving thought to that at the beginning of the process and try and making these buildings adaptable and flexible in the first place.
In order to justify their commercial existence, skyscrapers must be adaptable, with the ability to satisfy the needs of not just one, but multiple generations. And they also need to serve the public good.
As designers, architects, you have a huge responsibility to the cities and places that you're placing your buildings in. How do you integrate and connect your building into the location? What do you put back?
Really, tall buildings do have a responsibility to give something back to the public. You are taking away light, you're taking away air, you're always going to generate shadow. So what can you give back?
These buildings meet the ground. As they meet the ground, they spill out, they insert themselves into the context, and they sort of transform their context. So a tall building today, I think, would have to sort of consider, how does it meet the ground? How does it define a kind of urban space?
And buildings will not be loved if they do not connect and do not play a role in the city.